Hey everyone, Simon here with nut.js. In this demo, I'm using the Membrane Web IDE to show how nut.js can supercharge your Playwright tests. If you want to learn more about Membrane and how it makes building integration and automation workflows easy, check out membrane.io. Let's log in and explore why I chose this particular application. The interface may remind you of VS Code, but what's special about it? Well, once we open the inspect window, we can see that some parts of the UI are using canvas elements to render its content, e.g. the Membrane navigator up here. This means the entire area is invisible to Playwright. Why? Because the canvas element is the only thing Playwright is able to identify, since everything inside the canvas element is rendered using WebGL. Fortunately, you can still build end-to-end E2E tests for such applications using nut.js Playwright integration. This integration allows you to incorporate image search or OCR into your Playwright tests, enabling dynamic interaction with UIs like this one. Let's dive right into an example to learn more about this integration. We'll start with the default Playwright setup, following the official documentation. To use Membrane, we need to log in first. Let's write the Playwright code to enter credentials and log in. With the login in place, we can now focus on the nut.js integration. First, we'll install 3 packages: nut.js, the NL-Matcher package for image search, and the Playwright bridge. After installation, let's run a quick experiment to visualize the impact of the nut.js Playwright bridge. We will capture a screenshot at the end of the Playwright test, once we perform the login. Since nut.js is primarily a desktop automation framework, it captures the entire desktop, including both my browser and editor. Next, we'll enable the Playwright bridge by simply calling the usePage function and passing in the Playwright page instance for our test. After rerunning the test, you'll see that nut.js no longer captures the entire desktop. Instead, it focuses solely on the browser viewport of our current page, narrowing down the context for tasks like image search and significantly improving accuracy. Now, let's use the image search functionality to see how it works. In our test, we want to verify the successful creation of a new Membrane action. We can create a new action once the web UI has finished loading. So the first step is to use image search to dynamically wait for the UI to render. Using a screenshot captured with either nut.js or Playwright, we can extract the relevant portion of the screen. In this case, I'm selecting the new button that we will use later in the test. Nut.js simplifies handling dynamic content. We can pass the image resource we just created to the waitFor method of the nut.js screen instance, which continuously searches for a match on the screen until it finds one, or reaches a timeout. This is an efficient way to wait for the UI to load. If a match is found, waitFor returns its location, allowing us to move the mouse cursor to the center of the image and perform a click to open the menu. We'll repeat this process to locate and click the new action button. To complete the process of starting a new action, we need to name it. We can use the nut.js keyboard instance to enter text, as the nut.js Playwright bridge connects the keyboard to our Playwright page. The final step in our test is to validate the expected outcome. For this, the nut.js Playwright integration provides a set of custom Playwright test matchers. These custom matchers extend the default expect functionality to dynamically verify, for example, that a certain image is visible on screen or that the mouse cursor is within a specific region. So let's use one of these custom matches to confirm that our new action was successfully created to wrap up the demo.